This section covers 7.4, the other trigonometric functions. So in this lesson, we're going to work with cotangent, tangent, secant, and cosecant from the common angles on the unit circle, as well as finding reference angles and applying different properties. Okay. We have some ratios that we can jot down. So remember, if you think about SOHCAHTOA, you could also think of it as X, Y, and R. So sine would be Y over R, cosine would be X over R, tangent is Y over X, and then cotangent, secant, and cosecant are reciprocals of the first three. So cotangent will be X over Y, secant is going to be R over X, and cosecant will be R over Y. Okay. Now let's find the exact values of cotangent of pi over 3 as well as secant of 675. If you remember what the pi over 3 triangle looks like, it's a 60-degree triangle. I'll come over here and draw that quickly. Okay, so we know that we're going to have 1, root 3, and 2. So if we're interested in cotangent, that is the reciprocal of tangent. So cotangent of pi over 3 is going to be 1 over root 3. Okay. Now, if we're working with secant of 675, let's go ahead and get a reference angle for that. 675 minus 360 will get us an angle measurement of 315. Okay. Um, if you want to go ahead and continue finding a smaller angle, you can subtract 180. Okay, that is going to get you, let's see, 135. So now I know that I'm going to be in quadrant 2. Okay. And that means I'm going to have 1, 1, and root 2. And so we can say secant of 675 is going to be the square root of 2. Okay. If we want to find cosecant of 7 pi over 6, 7 pi over 6 is on the unit circle. If you wanted to find a reference angle, it would be the pi over 6, right? And that's also 30 degrees. Okay, 7 pi over 6, however, is in quadrant 3. So I do want you to remember that your signs are going to be negative in quadrant 3. So let's go ahead and draw that triangle. 1, root 3, and hypotenuse of 2. Okay, cosecant is the opposite of sine. So sine is 1/2, so cosecant is going to be 2. Whoops, where did we go? Okay. Cosecant of 7 pi over 6 will be -2 again because we are in quadrant 3. Okay. Now let's move on to this next page where we talk about quadrantal angles as well as any domain restrictions we might have. Sine and cosine are restricted to -1 to 0 to 1 for any quadrantal angle. And then if we think of the 6 trig functions, there are actually 4 possibilities, including undefined. Because if you have a denominator of 0, you would end up having an undefined. Okay. Jumping right in. If you are at 0 degrees, that's 0 radians, your sine is 0, your cosine is 1, your tangent is 0, your cotangent is undefined. Also, D and E does not exist. Okay. Secant is going to be 1 and cosecant will be 0. Then we have 90 or pi over 2, 180 or pi, 270 or 3 pi over 2, and 360 or 2 pi. Okay. We know the first three because we've already worked with them at this point. Okay, so we know that our sine is going to be 1 and our cosine is going to be 0. And in this case, tangent does not exist at 90, 180. Sine is 0 and cosine is 1. So therefore, tangent is 0. And then at 270, it's going to be -1 for sine, 0 for cosine, and doesn't exist for tangent, and then back to 0, 1, and 0. Okay. Now, for cotangent, it's going to be the opposite of tangent. So that means it's going to be a 0 and then a 0, 1. So everything is essentially going to be opposite here. So now for 180, our cotangent is not going to exist. And then we have a 1 and a 0. Here we're going to have 0, 0, 1, and then does not exist again, and then a 1 and a 0. Okay. Now, if we're interested in finding the exact value of tangent of -5 pi, I encourage you to go ahead and find that reference angle, right? So go ahead and add how many iterations of the circle you're going to need, in this case 6, in order to get pi. Okay. So what is tangent of pi? Well, we know that tangent of pi is over here. Okay. And so we know, based on what we just covered, that tangent of pi is going to be 0. Okay. Because we have a sine of 0, cosine of 1. So tangent will be 0. Okay. The signs of the trig functions we've briefly covered. Now let's kind of talk about which ones are positive and negative now that we've introduced the others. We have all positive in the top right corner. Okay. We have a positive sine and a positive cosecant in the top left corner. Okay. We have a positive tangent and cotangent in the bottom left corner. And then we have positive cosine and secant in the bottom right corner. Now, we also have even and odd functions, okay? Even functions are when you have an x value that's positive or negative that still results in the same y value, okay? Um, all of the outputs are going to be equal. Okay, all the outputs are going to be equal. So whether I plug in a positive one or a negative one, I'm going to get the same y value. Some examples of that are going to be linear functions, okay, quadratic functions, absolute value functions, and polynomials of a power that are even. Okay. Cosine and secant are also even function identities. Okay, that's why we kind of talk about it here. They're even function identities. So thinking about when you plug something in, here's your cosine. If you plug in a positive or negative, you still get the same y value. Okay. Then we also have odd functions, and that's when if you plug in a negative x, you get the negative y version. Okay. So if I plug in 1 and get 1, and then I plug in a -1 and get -1, those are going to be odd. Okay. Some examples of that would be a linear function with a variable, so it's not a horizontal line, an exponential function, or sorry, a cubic function, and the sine function, the tangent function, the cosecant function, and the cotangent function. Okay. All of those will yield a negative y value. And last but not least, a trigonometric identity is an equation with trig functions, which is true for all angles. True for all angles. Okay. Now, we're going to start building a list of trig identities that we're going to get really comfortable with. We haven't necessarily talked about all of these. They're going to be coming up. We've definitely looked at cofunction at this point. We have seen the tangent function as a relationship of sine over cosine, and we have seen Pythagorean identities so far. The others we may not be as comfortable with yet, and that is totally fine. We will get there later on in unit 2. Let's finish with these last two questions. Suppose that cosine of beta is negative 10 over 11. Find all 5 remaining function values if we're being told that beta is in quadrant 2. So that tells me exactly where I'm going to draw this. I know that I'm in quadrant 2. I'll go ahead and draw. I know that cosine is adjacent over hypotenuse. Excuse me. So I'm going to go ahead and find my missing value y using the Pythagorean theorem. That's going to be a square root of 21. Okay, we know how to do that. I'm going to skip that. And now we just need to finish writing out what all of these are equal to. So we have sine of beta is root 21 over 11. Okay, tangent of beta is negative root 21 over 10. We already have cosine of beta, so I don't need to write that one. Okay, then I have cosecant of beta. Cosecant is the reciprocal of sine. And again, as a reminder, I'm okay with not rationalizing. Your homework might require it. Okay? Secant of beta is the reciprocal of cosine, so that was already given to us. And then finally, cotangent of beta is the reciprocal of tangent. So that's going to be negative 10 over root 21. Okay. Now, this is going to change things if we move everything into quadrant 3. Okay, in quadrant 3, we're going to have a negative root 21. A negative root 21. So let's quickly draw that triangle here. So we had negative 10, negative root 21, positive 11. Okay. The only thing that's changing now is that we now have a negative root 21. So sine of beta is now negative root 21 over 11. Tangent of beta is now a positive root 21 over 10, right? Because we had a double negative. Cosecant is going to be negative 11 over root 21. Secant is going to be the reciprocal of cosine. So negative 11 over 10. And then cotangent of beta is going to be the reciprocal of tangent. So 10 over the square root of 21. Okay. I encourage you to get really comfortable and familiar with these types of problems. You are going to be doing them quite a bit in the homework as well as in the rest of the semester. And that covers it for 7.4.